let's get started then. So before even we begin, typically we put a tagline with our company's name, our startup's name, that we say we are leading creative learning. Because we believe learning is not a monotonous process where we just learn the syntax of a language and we directly start coding. So we will not begin and jump into Java straight away. So before even we start, let me talk about story of an engineer. So this is story of an engineer. By the way, you can see the pic and you can tell like he's not a software engineer. So when this guy with his friends, he went to a jungle and they were planning to do some construction over there, he noticed a beautiful girl. So she was sitting in that beautiful scenery backing her, and when he saw her, a strong desire came into him that I want to go and meet that girl, I want to talk to that girl, I want to have a word with that girl. Now when this desire, this strong urge emerged into him, he used to watch a lot of Bollywood movies. So he had that urge, and through movies he also had an inspiration. So he knew a film star here, and he has seen this film star going and talking to any girl confidently, as if like everyone will know him. So there is a famous dialogue by him that says, "Hi, I am Raj, and you would have already heard my name." So this guy also got the inspiration from that person and went to talk to that girl. And now when he was talking to that girl, he was saying something to her, but she was not able to understand even a single line. So this guy thought maybe she is deaf and dumb, she is not able to hear me and she is not able to speak. But to his surprise, after some time, this girl spoke. But she was speaking in a language that this guy did not understand. So now he got into this challenge where he wants to talk to the girl, he's saying something to her, he's asking her name, he wants to know where she is from, but she is not able to understand him. And same is the case with girl, she is speaking something which this guy is not able to understand. So that's the dilemma he was in. And at that time, when he was thinking about what should I do, how should I have a conversation going with this girl, and suddenly at that time, what happened? A leaf fell from a tree. And when the leaf was falling, this guy got an idea, because as an engineer, we don't leave any problem unsolved. Even in our exam copies, if we don't know answer to any question, we still write something or the other. So this guy also did not want to give up. He wanted to do something. He wanted to find solution to this problem. Now what solution he found was, basically he took this leaf and he went to the girl and he gave her a pen, assuming like she will write something, she will scribble something that this guy can understand so that a conversation can go on. So he handed over this leaf to that girl and girl scribbled something on it. And this is what she had written. She drew something. We can see there is some small, on red side there is some small symbol she had drawn and something she had written. Now when she wrote that, this guy realized, okay, she knows a language which is not known to me, so even written communication will not work here. Now what should I do? He faced the next problem and he started thinking about solution to this next problem. And what came to his mind was, why not ask this girl to hold this leaf and he will click a photo of that girl with this leaf. So that will serve two purposes. This guy can take this scripture to someone else and ask what she has written, plus he will have photograph of that girl. So he took his phone out and he asked that girl to hold this leaf so that he can click the photo and take help of someone else to decipher this message. So he clicked that photo, and after clicking that photo, he was still not satisfied. He was like, I don't know when I'll get a chance to meet her again, even after deciphering the message, whether I'll come back and talk to her or not. So what he did, he started with one request, and that request was he wanted to have a selfie with that girl. So he took his phone out, and he showed it to her, indicating like he wants to have a selfie of this sort. And girl did not object, so this guy assumed, okay, that's a permission to take a selfie. So she came and stood on his side, and this guy clicked the selfie. But when he was clicking the selfie, he didn't realize at the time the click happened, the capture happened, the girl was looking at his face. So girl's face was not there in the camera. So she was looking at the boy's face and his face was in the camera. Anyways, after he clicked the selfie, that girl ran away and this guy came back home. So that's the story. He met a girl and they did not know the language of each other. He asked her to write something she had written, but again he was not able to understand what she has written. So he has clicked a photo of what she has written along with the girl, Plus he has taken a second picture of the girl with him. So that is what happened till now. Now when he went home and he looked at the selfie that he had taken of both of them together, and to his surprise what he found was, in selfie he was not there, girl was not there. Selfie had a small kid in that pic, that was him, and in place of girl there was a laptop, and laptop was staring at this boy. Then he realized when I was clicking the selfie that girl was also looking towards me. That is what was there in the picture. And now he was restless. Where do I find the message that she had written? So can someone suggest where will he find that message? Anyone?
In the lab.
In
the computer maybe.
Okay, but in this picture, computer is not facing outside. Like we can't see what is written on the computer, right?
Yeah.
So where is the message that she has written? He clicked another picture also, where girl was holding the leaf in front of her, and that time she was facing the camera. So he had a second pic, right? Yeah. So he looked at the second pic, and to his surprise, second pic had that written scripture in his hand, but the girl was again replaced by a laptop. That is what he saw, but he got the message that she has written, which is what he was searching for. So he was surprised, he was confused, what all happened to me? Like this has never happened before, that I take a photograph and people get replaced by something else. So what he did when he fell into that dilemma, he needed help. So he went to a wise person who was a Siddha yogi, and he went to him to seek his help, and he told him all the story that happened with him. And to him he said, I don't know which language this is, but I need your help in deciphering this message. By the way, anyone recognizes the person who is sitting here in this pic?
Modi, yeah?
Yeah, that's Modi. Yeah, that's our PM. Okay, so he went to PM, that he is the wisest person here and he will help me probably. He's running the country, so he can help me with my small ask. Now after hearing his story, this person puts a condition in front of him, and the condition is, he says, I will tell you what is written in the message. I know what language it is, I know what message it is, but you have to make a promise to me, you have to make a pledge that after I tell you what language it is, what message it is, you will learn this language and you will go and talk to that girl again, and you will express whatever you want to say to her. That's the promise. If you are ready to make, I am ready to tell you what's written in this for you. So what will this guy do? Will he make the pledge? Will he make the promise or not?
Of course, yeah.
He will do.
Of course he will do. Okay, so he did that. He took that pledge. He said, yeah, certainly I make that promise, I'll do that. And after that he was told what was written in that message. And we see what the message was.
Java.
Yeah, so it's written Java. So that's the language. That's the language to learn to talk to that girl, and we know who the girl is now. So moral of the story is, when we took admission into engineering, or when we actually joined the job of an engineer, that time we made a pledge that we will build something. So that is a pledge that we had made long back, or at least we made a pledge that we will become an engineer who is able to express himself through computers. We should be capable of building something that is useful to us as well as to others. So that's a developer's promise that typically we make to ourselves as a computer science student, as a computer science engineer. So we know our first feeling, we know the pledge we are making, but after making that pledge, somewhere things went wrong, somewhere we were not into the game, somewhere circumstances were not in favor, and that promise, that pledge is unfulfilled. This is our chance to fulfill our dream, to learn this language and to talk to this machine, to fulfill what we wanted to achieve, what we wanted to do. So are you ready to make this pledge and to run and win? So that's a question that is for you. So I mean, since you people are online, I can guess like you are ready to make that pledge. So that's an assumption I'm making. If my assumption is wrong, you can speak about it or you can type in the chat window. Okay, great. So with that, we move forward, and now we start with the introduction. And Basically, this training is conducted by two of us, me and Ashutosh. And Ashutosh, at last moment, he had some work because of which he had to go outside Hyderabad. So he's not here, but upcoming sessions, both of us will be there in the sessions, and some topics he drives. He has his unique capabilities in taking certain areas, and I have some areas where I excel. So we are the two people who will be taking this training. Now let's do a brief introduction about both of us, because Ashutosh is not there, so I'll be doing his introduction as well. So my name is Sandeep Kumar. The left side picture that you see, that's me, and the right side that you see is Ashutosh. So both of us, we are classmates from college time. We are from NIT Allahabad, and 10 years back we joined Microsoft, both from the same college. We joined together, and we worked there for 9.5 years. And after that we started having a discussion about, like, when we were students, there were a lot of things we didn't know that we have come to know about in these 10 years. And they were not rocket science, they were not very tough things, but had we have exposure of those things in college time, then we would have become much efficient and productive software engineer. Then when we went around and saw what is the state today in engineering colleges, we found the state was same. There are students with a lot of dreams, a lot of passion to learn something and to build something, but again they are in the same kitty where sometimes learning is missing, sometimes the direction for them is missing. So we thought, let's take some break from our jobs and do something to help a student that was there in us who lacked the guidance, who lacked the direction. And we started doing some work of inspiring students to learn programming and to do something that helps them become a good software engineer. So that is where we started this startup named Being Zero. So our goal with which we started this was, we wanted to revolutionize the technical education in India, especially because in India students lack motivation and exposure. So we thought, with such a great population, if we can bring one small change and that has a huge impact, that will be really fulfilling dream to accomplish. So that is the goal towards which we are working. So this is our page, and it will have a lot of pictures of what workshops we have done in which colleges. So all these pictures that you are seeing, these are mostly nearby colleges to Hyderabad. So these are the students who experience the joy of learning and building something. So like this, we have been running these initiatives for past 1 year. And yeah, this is our Facebook page, then this is the email ID, and we have site also. I think I forgot to put the link of our website. So this is what our website looks like. You will be mainly referring to Java section here, because we keep uploading various quiz questions that help you kind of revise the concepts that we talk in our classes. Well, so that was about us and about our company. Fine. Sarita, I hope you got the answer of introduction that you asked in the beginning.
Oh, yeah.
Okay, cool. So let's get started. So fine, we started with a story, and story was about we should learn a language which helps us talk to a machine which is powerful, which provides us entertainment, which provides us knowledge, which provides us a way to communicate with others. Such a powerful machine, why we should not get a chance to talk to that directly, and we should be able to achieve what we want to. Okay, there are a lot of languages, a lot of programming languages using which we can talk to computer. But why especially we say Java is important language to learn? So initial few slides, because this is introduction class, I did not want to jump into Java directly, because more important question to understand is why we should learn Java. Once we are clear about that, once we know why we are doing certain thing, the passion and the energy comes from within, and it allows us to go a long way. So let's talk about this question, why we should learn Java. Now first thing is, computers understand binary language, a machine language, and if we have to learn the binary language, it will take a long time. So Java is a high level language which is easier for us to learn than the language that computer understand. So we learn Java, and which is a lot easier for us to write, and then somebody helps us convert that into machine language, and that's how we run our code. So that is first bullet point. Before we go to the second point, let me raise that as a question to all of you to ask, why we should learn Java. Why not C? Why not C++? Can anyone answer? Few reasons or one reason where Java wins over other languages. Srinivas, Sushma.
It's a platform independent.
Okay, it is platform independent. Very well. Yes. So one advantage is Java is platform independent. Yeah, Sarita, you had any point to say?
I can say Java is a very popular language, I can say.
Okay, that's also a valid point. Java is a very popular language, and the popularity stems from the reason in Java we can write web applications, we can write desktop applications, then we have mobile application development, and Java is kind of everywhere. So popularity, that's also a valid reason why we should learn Java. Any other reasons, Sushma? Or any other reasons, Sarita, Srinivas, you people have?
The open source, one thing.
Great. Yeah, Java is open source, so that makes another big advantage. One advantage with open source languages is there is a whole lot of community that is supporting it and extending it. Basically, if you get an idea, okay, in Java this thing is good to make, people form the groups, they form an open source group and they start contributing to that code. So that way enhancement, imagine like a company of 1,000 people developing a language versus open source project which is backed by millions of people. So the one which is backed by millions of people is certainly going to expand very fast and is going to have a lot of features. So that's the reason like being open source, Java got more popularity. Now let's take a few more points, look at few more points which tell why Java is important. So first point that we have captured here is it is platform independent, as Srinivas mentioned, that you write program in Java and that program can be taken to Mac, Windows or any Linux based distribution, and we can take that program directly and we can run on those machines. So platform independence is one reason that Java is popular. Second, Java has inbuilt support for building GUI applications. We can make this form in no time in Java. This support is inbuilt. This support was not there in C++ inbuilt. In C or C++, if we want to build the GUI, we have to rely on third-party libraries. Language inbuilt does not have that support. Next, Java has support for building multi-threaded applications, and this support is also inbuilt into Java. If we have 4-core processor and we want to do 4 things at a time parallelly, then Java provides that support inbuilt. That means if we learn Java, then one more concept we master and our applications will become multi-threaded. So that is another good reason of Java winning over C++. Then Java supports internet programming. That is what I think Sarita pointed out, that it has a lot of popularity because it has wide variety of applications supported. Then it has rich inbuilt class library. In Java, a lot of classes are there which we can directly reuse. We don't need to write the code from scratch. If you want to sort an array, we don't need to write more than 2 lines of code. So that is the kind of rich class library with which Java comes, and day-to-day tasks that we can think of, they are already automated and given to us as class library. And last, it supports many types of applications which includes web, applets, desktop and mobile that we are all aware of. So these are good enough reasons of why we should learn Java. Apart from that, one more reason you will pointed out was it's open source, so its expansion and its support is many-folded. So well, now we understand why we should learn Java. Let's take a look at one more advantage that Java has, and that's typically an interview question also. What makes Java platform independent? Typically we say C++ programs can also run on a Mac, or they can also run on a Linux box. Then why do we say Java is better than those languages? So let's take a look at here. Now we said in Java, basically Java is kind of providing us a way of communicating. Like Java is like a translator for us. We talk the language of Java and Java converts it to the language that other person understands. So it is kind of a translator between two of us, where we know Java and computer knows machine language. So this person in middle, his translator over here in this conversation, So these two ladies who are talking to each other, they don't understand each other's language, but this guy is helping them achieve that. Now this model that we see in this diagram, in this picture, it is a C++ model, and this model is something like this. That we write a C++ program, and then Windows is there, Unix is there, Mac is there. So on all these three platforms, we need three different compilers. Our C program, Windows compiler on Windows box, it will convert into machine language. So this is a different translator, this guy is a different translator, this guy is a different translator. That means even if we have written a code in C and C++, we need three different translators to talk to three different platforms. Now this is something that Java addresses in a better way. Because in C, we have an overhead of compiling this program 3 times. In Java, what happens is, Java says, you have one compiler for you, single compiler, you compile your source code. After compilation, whatever output it produces, that output can directly be taken to Windows, Unix or Mac, and it can directly be executed. So the main difference is very important to understand here. C program needs to be compiled 3 times in order to run on 3 different platforms, but Java program needs to be compiled only 1 time to run on any platform. So ideally I will say this feature is compile once, run anywhere. Typically people call this feature as WORA, which is write once, run anywhere, but Java truly supports CORA. People also say Java is WORA, but mainly at ground level it is CORA, compile once, run anywhere. That means we don't need to recompile our code if we want to run the same code on different platforms. And we will see a live demo of that also very soon. Now this same model of Java, we can see Java execution is 3-step process. We write a Java program which is compiled and a class file is created. Now this class file is interpreted by an interpreter, and interpreter converts into machine language. So it means there is not a single translator in between. There are two translators. This translator creates an output which is one class file, and this class file can come from either Windows machine or Linux machine, but this class file is not going to be different when the compiler is run on Windows, Mac or Linux. That means one file which is output of compiler can be run on any platform. So this concept and this intermediate file that is generated here is called bytecode. So one concept behind Java's platform independence is this file which is bytecode. We'll see these terminologies and these details also. So this is the true diagram that tells how the Java compilation and execution happens. So we write one Java program, we give it to a compiler compiles it into a file which can be executed on 3 different platforms, because on all these 3 platforms there is another program, another interpreter sitting, which is called JVM, and JVM stands for Java Virtual Machine. So that is Java Virtual Machine which can run bytecode, bytecode is generated by the compiler. So Java Virtual Machine is written by the Sun Microsystems originally, and now Oracle owns it. So JVM here is unique. I mean, for Unix there is a different JVM, for Mac there is a different JVM, for Windows there is a different JVM. Now because of this JVM, we can give compiled code to this JVM, and JVM can translate into individual machine type of code. So this is the introduction of JRE and JVM. Now let's talk about this slide. Now Java is distributed in 2 variants. So Java environment, whenever we say we are installing Java, because all these machines, 3 machines that we are talking about where we want to run our code, they should have JVM on them to run the compiled code, because bytecode is always understood by JVM and JVM runs it. So 2 variants of Java that we get that are shipped, the Java is shipped in, they are called JRE and JVM. Now what do these 2 terms stand for? JRE stands for Java Runtime Environment. Java Runtime Environment is kind of an environment which allows us to run the Java code, which basically in this diagram, if we say, it contains JVM in it. Now let's say in our office there is a machine on which we simply want to run the Java code. So if we want to only execute the Java code, we can simply install JRE on that, which is runtime environment, which will execute our Java code. But if we also want to write our code and compile our code, then JVM does not have support for compiling our code. So this compiler is a separate component, this JVM is a separate component. They are linked together by JDK. Now JDK is Java Development Kit, which brings compiler and JVM together. So that is what we will see now. So one is JRE, second is JDK. JRE is a piece which contains JVM as part of it, because this is only runtime environment and it has JVM, which allows us to run the bytecode. Now JDK is a superset which has JRE as part of it, plus it has some other tools which help us compile our code. So let's take a look at the detailed definitions of these two terms. A software program that is necessary only for execution of Java bytecode. It consists of a Java virtual machine, runtime class libraries, because some class libraries, which I said Java has inbuilt support for a lot of classes, so those class libraries also come with JVM, and it has application launcher, because if JVM is installed on a machine, we should have some way of telling JVM, hey JVM, run this compiled code. So those are the launchers, and we will see them practically after this slide. Second portion is JDK, which is a software program that consists of JRE plus set of tools that are required to compile programs. So JDK is nothing but JRE plus compilation and debugging related tools. It consists of tools required for building and debugging applications, applets, and components using the Java programming language. So there are some more components which Java programming language will require in order to build them. So I hope these definitions are clear. What is JRE, what is JVM, and these basic concepts are kind of sometimes in interviews people focus on. They try to understand what is the difference between JRE, JVM, do we understand them clearly, and what is the relation between JVM, JRE and JDK. So key takeaway from this point is the relationship between these three. Now let's talk about our machine setup. Now we are ready, we want to do Java programming, we want to develop our Java programs. So we have a machine, it may be a Windows machine, it may be a Mac, or it may be a Linux machine. So where do we start? So I have a fresh machine, because on this machine I have Java already installed. So I thought we'll do a live demo. So this is another machine that is there, a fresh machine which just has OS installed, and I have installed 4 browsers on that. But Java is not there. The first question that comes to mind is, how do we validate whether this machine has Java installed or not? So on Windows we can open command prompt and we can go and type Java, enter. So here it is saying Java is not recognized as internal or external command. If you are using Mac, then you have to go to terminal and you have to type this command Java. If you are using Linux, there is terminal and you can use that. So I have another video recorded on Mac platform. In case there are people who are using Mac, so Java is platform independent, so you can use any operating system. So I will share those that video and the installation instructions of Java on a Mac machine. So here we are going to see a live installation of Java on Windows. Now one question before I do the installation, let me ask, on this machine should I be installing JDK or JRE? Yeah, can somebody answer?
JDK.
Yeah, JDK, and reason behind picking JDK is?
It has both JRE and it can install compiler and JRE as well.
Exactly. Since we are interested in writing our programs and compiling our programs, and we certainly need compilers. So for compilers we need to go with JDK. So in order to install JDK, let me open the browser. So I'll open Chrome and we will search in Google for download JDK. Let's search there and we will see what results come. And we see on top there is Java SE download. So Java comes in SE version and EE version. So we'll go with SE because that is where we will get a JDK. Now here when we come, we can clearly notice that it says Java Platform Standard Edition, and we can see JDK is there and 2 JREs are there. Now why do they ship JRE separate is because if we have server machines in our office and we want to deploy our application, we want to distribute our application, then to people who are consuming our Java programs, we tell them to install JRE, because our customers, they don't need to do development, they just need to run our code. For them, JRE suffices. For us as a developer or as a test development engineer, we go and we install JDK. Now this is the download we need, JDK. So let's click the JDK. And when we click the download link, here we can see there are installers for different OS platforms. So here we can see first few are for Linux, then we have Mac installer, and then Solaris, and last is Windows. In Windows we can see there are two flavors, x86, x64. Now which one should we pick is dependent on our what kind of OS operating system we have. So on Windows we can go to my computer, I can right click this PC and let's go to properties, and here you can notice it is telling this is 64-bit operating system, x64 based processor. So whichever is our operating system, we have to go with that version of Java. So this is x64 version that I need to download. So here you can see there is a Windows x64. If on your machine it says your machine is 32-bit operating system, that means you have x86 based machine. So accordingly we have to download and we'll be installing that. So since this is 186 MB download, so before the class I downloaded this so that we can save some time. So this is what I downloaded half an hour back, and this is x64 version. So let me double click to install it. Okay, so let's begin the installation. And we have to accept all the defaults, so there is no change that I'm going to do to any configuration. Simply keep going and keep hitting the next button. And once we do the installation, it will put the Java installed files, basically all the compilers and all, in program files directory in case of Windows. So basically after that we'll have to take one more step, which is listed in the slides as well. First we need to download and install JDK, that is what we have started already. Then we add compilers to the path variable. I'll talk about what path variable is, and after that we become ready to compile and run our Java program. So these three simple steps are there to be ready to develop in Java and to run Java code. Okay, it is taking some more time. In the meanwhile, let's talk about what the path variable is. Now if I open command prompt on my this development machine, here I can write notepad and enter, and it immediately launches notepad. If I write calc calculator, it will launch calculator. It will figure out where the calculator is. Wait, it's not yet launched. Okay, ideally it should have launched. Let me do calc.exe. Okay, here it is. So basically our command prompt is able to figure out where the program is. There is a small command where calc, if I hit enter, it figures out it is there in C Windows System 32. But right now I am in my user directory. Now how command prompt is able to figure out where these exes are? Command prompt has a variable called path. In that path, whichever directories are added, command prompt goes into all those directories to search if those directories have calc.exe. If it finds that somewhere in any of the directory listed in path variable, it picks it from there and it runs it. Now path will be a variable like this. Path will say C Windows. This is one directory in path, and then we put semicolon. Then we say C Windows System 32. That is another directory where exes will be there. Now when we run a command, let's see if I run a command abc.exe. What command prompt will do? It will go and look in C Windows. Is it there? It will go and look in C Windows System 32. Is it there? And before all of that, it will look in current directory where I'm sitting. So I'm sitting in C user Sandy. So it will first search in current directory. If it doesn't find it, one by one it goes in, searches in all the directories. So that's the reason we add our compilers to the path variable, so that in command prompt we can go to any directory and we can compile our code. Well, so here it is asking, our installer is asking us to go ahead and hit this. So this will start the installation. Now once Java is installed, two things happen. One, it will install java.exe, which is automatically added to path. Second is javac.exe. This is the Java compiler. So compiler is not added automatically. So if we were to run any Java program on our machine, we don't need to do the path setting, because we can run ideally any program that we got compiled from other machine. But if we want to compile our program, we add it to path variable. Now let's take a look at what is the way to add a directory to our path variable. It's simple. Again we go to system settings. So here I opened the PC settings, which I did. I went to my PC or this PC in the file explorer. I right clicked here, went to properties, and this is what it opens. Then we go to advanced system settings, and we will find environment variables here. We need to follow that, and here in system variables we'll find an environment variable named path. Now this is the path variable that we need to edit. Okay, installation completed, we say close, and this variable we have to change. Now if I go, I have to exit the old command prompt and I have to launch new command prompt, because now we have installed Java, some exes got added to the path. Now if you see I run java.exe, it is able to run something here, and if I say java.exe minus version, then it will tell which version we have installed. So this is a validation of checking whether a machine has Java installed or not. Now if I do javac.exe, it says I don't recognize that, because compilers are not added automatically to the path. So let's go and add our compilers too. So installation typically happens in C, program files, Java, and okay, I have two variants. Let me go and look at what is the latest one. So latest is this. Okay, one is JDK, one is JRE. It seems I had a previous version of JRE also installed, only JRE. So I go here in this installation. We have to go to JDK folder, bin folder, because that is where our compilers will be. So this path where JDK bin is there, we copy from here. We go to our environment variables, we select path, we say edit, and in the end we put a semicolon and we add one more path, and we say okay, okay, and okay. So this way what we have done is, the environment variable that I was talking about, in path we have gone ahead and we have put one more semicolon and pasted a path, so that our command prompt can look in one more directory whenever we are compiling our programs. After doing that, if I go and run javac.exe, it will still not recognize, because whenever we change the path variable, our command prompt should be restarted. So this old command prompt knows the old variables. So let's close this. Let's start a new one, and this time javac-exe -version, if we run, we can see it recognizes javac also as a command, and if we do where javac.exe, it will tell us where it found that. It found in that directory, because that directory is added as a, or that folder is added as a path variable. Well, so we are ready. We have done our machine setup and we have Java installed and we are ready for development. So let's write our first program. So before writing the first program, let's understand what is Java structure. So Java program structure basically. So I'll write a program, let's say notepad, and say first program.java. So it says that file is not there, so we hit Y or we click this yes button. We are creating our first program. Now any Java program that we write, typically we have to write the class first. So this is a fixed syntax. Let me increase the font. So font of 16 will be good. Okay, so we say public class and the name of the file that we have given, it is case sensitive. First program, same name we have to give to our class. Later on we will talk about why that is a requirement in Java. But for now, just remember whatever name of the file we have given except .java, that will be the name of our public class. So we say public class first program, that is first requirement, and then inside we write public static void main. Inside there is string args. Now these two things that I have written here, a class and a main function, these are mandatory. So you can say these 4 lines of code, they represent start of any Java program. So first 4 lines are start of any program, and last 2 closing brackets, they are end of any Java program, and these are mandatory. Now in every program our class name will change based on the file name, but this much piece of code we will see in every Java program that we are going to write in first 2 or 3 classes, and then we will go on to the complex programs. Now when we have a start and end, you can visualize this as start, this as end, then whatever code we write inside main, that is the code where the execution begins. Now here we kind of write some code where we either take user input or we show user an output, and last thing that typically we do is we use some inbuilt classes and their objects. Now if these are the things that are there in our mind, then Java is not a very difficult language. So this is the beginning thing of Java. If we have always this picture in mind, then half of the problem of Java is solved. Another half will come when we talk about what are the inbuilt classes, how do we use them, plus how do we create our own classes. So that I will say after initial few classes we'll move there, writing our own classes. So these 4 things is the crux of complete Java. Now in this class, since we are going to go step by step, in this class we'll focus on writing something that shows user an output. So let's begin with that. So I'll save this program structure so that I can share this content with you as notes later on. So let me copy that. Yeah, so this is our first program, and this program we can directly go and compile, but we know in this program we have no code written. All these 4 lines that we have written with double slashes, they are just comments. So I can simply go and remove them. So this is a blank program. As of now it is saying I'm doing nothing. So let's change this program and show some output to the user. So we will say system.out.println. Now this is something we use to show output to the user, and here we say I am learning Java. So we are calling some function, and anything that we want to show to the user, that we write over here, and we save this file. Now we have written our first program which produces an output. After writing the program, we go to the command prompt. First thing that we do is we take help of compiler and we ask compiler, can you convert my program into bytecode? Because remember we talked about Java has 2-step process. One step, convert our code into bytecode. Second step, ask Java virtual machine to execute this code. So we are going to follow the first step now. First step is compile our code. To compile, we simply give java.exe and abc.java, where abc stands for any file that we have created. Now in this program, if we see, if I do dir, that's a way of listing the directory contents, or I can do start dot, it will open the directory. We can see our first program.java is here. Once we compile our code, we will see another file created here, first program.class file, that is compiled version of our Java program. So let's do that. Java C. Now exe is optional. If we write exe or not, that's up to us. So we'll use the convention of using Java C, and then we have to give our program name. Even that is easy. If I write fi and hit tab, then command prompt automatically finds out a file which is there with this name. So if there are more than one file, it kind of two tabs will take us to the right file. So I could have created another file. First time I hit tab, maybe if I create a first apple.java, then first apple will be listed first. Then I hit another tab, it will go to the second one. I'll show that also here. So let's say dir, I did java de. If I write only D, hit tab, it lists desktop because that's a directory. If I hit tab again, it goes to document. Tab again, it goes to downloads. So with tabs, we can keep switching between various files. So whenever we are compiling our file, we can give first 2-3 letters, hit tab, it will list that file here. Now we are compiling this file, so we say java c and we hit enter. Now if there are no compilation errors in our program, then it will produce an output file whose name is same as our original file firstprogram.java, and output is firstprogram.class. So we have got bytecode of our Java program. Now second task that we have to do is we want to run our bytecode. And in order to run, we use another exe, which is, okay, first I wrote it wrong, sorry, it should be java c. Second one is java, and we give only abc command. Now a common mistake people do is they write abc.class, which will not execute the code. When we want to execute the code, we just have to give our class name without extension. And at the time of compilation, we have to give extension as well, .java. So here if I go and say java space first, again I'll do tab, it lists the class file, and we will remove the .class, and let's hit enter. And when we hit the enter, this program, so java.exe invokes JVM, it tells JVM, hey JVM, can you run the code that is there in first program? And JVM searches for main function, and whatever is the first line in main, it starts executing that line, and whatever that line says to do, it does that. So we can see there is an output that is printed over here. So I think this is probably that most of you would recognize. Typically whenever we learn Java, this is the first program we write. Now I'll show you another way also, where I want to touch base upon one more thing. We use some inbuilt classes and their objects. So Java has an inbuilt class which can show this output even on a GUI, on a window kind of thing. So there is a class, we will talk about that class later, but this is just to show you another way of showing a user output is, there is a class called JOptionPane dot show message dialog. Now in this, when we call this function, we have to give two arguments. Here I can say I am learning Java. Here goal is not to kind of confuse you or to tell you like there is another way and this you should recite, but this is something that you will become comfortable by the end of these classes. You will start using this code without even me telling you anything, so we'll reach that level also. But here just wanted to show you another flavor, because we talked about the good features of Java and why we should learn Java. So we are using another class called JOptionPane, and this class resides in another package which is swing. So if we are using some class of Java, we have to tell the compiler where the class is. So I'll use java x.swing.star. We just modified our program with two more changes. First change what we did was we changed the function that we were calling. Let me go and paste this program also and the previous one as well, so that we have these notes preserved. So previous one we wrote was system.out.println, and that was showing the console output, and we did not have this. Now this program that we have written is we are using another function to show user output, and we have used import statement. Now let's save the code, go back. Since our source code has changed, we have to compile again. So I have hit up arrow 2 times to go back to the old command that we have typed in command prompt, and let's compile it again. Now this program compiled. Let me hit again down arrow to come to the second command. So this up arrow and down arrow allow us to go back to the old commands that we have typed in the command prompt. Very convenient way to run our code. Now I am executing this code with Java command. Let's hit enter, and we can see this time the message we are seeing, it's not a console based message, it is a GUI based message. Now how easy it was for us to show a dialog box to the user and tell that this is the message I wanted to convey to you. That is where the Java wins over other languages that typically we start learning as a student. So any questions till this point? Okay, great. So let's summarize what we did. We wrote our first program. This is the program. Then we saved the program, we compiled it, and we executed it. If you don't have any questions, then there will be questions from our side. So let's start with questions from this side. So first question, you can speak about what is the right answer here. So these are knowledge check of whatever concepts we have talked about till now. What is the command to compile a test.java program? A, B, C or D? Yeah, Srinivas, was that answer from you?
Yes.
Yeah, so what is the answer? It is
C.
C. Yeah, because we are compiling. Yeah, so it is C because this is the Java compiler. Next question. What are core concepts behind Java's platform independence? Yeah. Anyone? It is B. It is B. Everyone?
Mm-hmm.
Yeah.
Yes.
Yep. So that is B because it's bytecode and Java virtual machine two-way process that makes it easy for running this code. There is some explanation included here. Next is which all of the statements are true about Java? Select all that apply. Is A true? Java is also called JavaScript.
No.
Yeah.
I got mixed responses. Did someone say yeah? Okay, one point to clarify here is JavaScript is a different language, which is language for development of a web that adds interactivity to the web pages, and Java is a separate language. So this is a common confusion that happens. So they are two different languages. So B point, first point we saw it's not true. B, is it true or false?
It's true.
True. True.
Yeah, B is true. C,
True.
C is also true, and D,
True.
D anyway Srinivas pointed out in the beginning that it's an open source. I think Srinivas or Sushma pointed out. Yeah, so B, C, D are true. The A is false because they are two different languages, Java and JavaScript. Last question. In order to compile our programs on a machine, we must install JRE. Is it true or false?
False.
Okay, Srinivas says it is false. Sarita, Sushma?
False.
I mean, I guess, yeah, we need JRE, which is a subset of JDK.
Mm-hmm.
So, yeah, basically we need to have the compiler too.
Yeah,
So that comes along with the JDK.
correct. So JRE itself will not allow us to compile the code. And here we are talking about if we want to compile our program. So we need JDK. So the catch here is if we want to compile our code, then JRE will not suffice. It should be JDK. If it was in order to execute our Java programs, then JRE would have been right. So here answer would be false because we need JDK. Yeah, so that is A answer, which is false. And here the explanation is which we have already talked about. Well, so that was a quick overview of getting started with Java. Now let's take a look at what is going to be in our course, what is planned as the course content. Let me open. So has everyone taken a look at the syllabus? Okay.
Not it, Sumit.
No, no.
Okay. Okay, great. Then I'll walk you through the syllabus, what is planned to be covered. So basically this is divided into 4 separate modules, this complete syllabus. And the first week we are going to talk about develop a problem solving mindset. Basically, if we are given some programming problem, typically that happens in interviews also, somebody will say, okay, write a program to tell a given number is prime or not, or it may be another sort of program which typically people ask in interview. If I give you number of seconds, which is let's say 10,000 seconds I give you, can you convert in days, hours, minutes and seconds? Can you write a program to do that? So these kind of problems when we face, then what should be our thought process behind solving those problems? So that is what we typically begin with. Then we have a discussion of JDK, JRE, JVM, which we have already done. Then after thinking about the logic for any given problem, the next challenge comes is how do we convert that into code? So in order to convert it into code, we talk about the variables, data types, then we talk about input output statements, then we talk about some classes, and there are a lot of exercises that we are going to do on decision control, loops, functions. So next class that we will do, there will be some programming problems that we will bring in and we will discuss the ways to solve them. We will be writing code of those problems together in the class, and after that there will be some exercises given to you so that in your free time you can also spend some time to practice the code yourself. And typically one thing that is very true to understand, and I think you will all agree to that, is if I see someone driving a car, no matter how much he explains to me, how better he explains to me that this is how you press the clutch, this is how you accelerate, we can get the theoretical knowledge by listening to people, but we will not be able to drive the car until unless we sit in the driver's seat, we press the accelerator. Because typically I have seen, whenever I was learning the car for the first time, I was explained very wisely that these are the steps you have to do. So I kept all the points in mind, but when the first time I was driving the car, I put it in gear, and whenever I accelerate, it will stop with the third. I mean, it will just get stuck. And that is same thing that happens with programming also. So even if I am coding in the class, same set of problems that I do here, it is better if you go and do that yourself on your PC, because that is what it is going to make you comfortable in programming. And that's the mistake that most of people in past have done. They come back and they tell that I have taken 3 programming courses on Java already, and this is the 4th one I'm going to attend, but all 3 did not make me learn programming. I'm not yet comfortable in doing programming. One simple question I asked them, did you see someone else coding or did you code yourself? And most of the people answer that we saw other person was coding and it appeared very easy to us, that programming is easy, and we always had a feeling that we will be able to code. So this is the difference and this is the mistake that we make. So one programming language I would have mastered in my college, but I also made that mistake in my life, that when I see others doing, we feel like this thing is very easy to do. So here, to take the maximum benefit of these classes, I'll say spare some time, because it is just 1 month's hard work that you are going to put in, and you will see benefit of that you will be reaping throughout the life. So a lot of exercises will be shared in the first half to make you roll the car so that you can drive the car in parking, and that is very important before you can take the car on a freeway and drive there confidently. So here we are going to spend significant amount of time so that the journey to the later and advanced concepts become very easy. So mostly we will spend 1 weekend complete on the first module, and to make every module interesting, we also include some GUI based case studies, which is not plain console based applications, but we will be doing something interesting where you can do a small application which helps you apply your concepts and you can make a GUI application. So I'll show you an example. When we talk about arrays, we do one simple card drawing application. So this is one simple application. You click deal button and you see one card comes here. You do another deal, second card, third card. So these cards are coming. This is an application of arrays. It just makes learning array much more fun filled, and building this kind of application in Java, it's very easy. So you will see that yourself. So in first week when you are doing the loops, decisions and arrays, you will see all these three concepts will be combined together to make this application. And then to add complexity here, we add another button called shuffle. When you click the shuffle button, these cards will start coming in random order. They will not be in sequence. So this is what is listed here, deck of cards that we do in first week. And there is one more simple calculator that we do, which is not the full-fledged calculator, but again a GUI. Okay, I don't have a jar file here to show you that, but we will do these two case studies so that it gives you an opportunity to apply the concepts you learn in the classes to build something from scratch yourself. After that, today we did a quiz inside the slides. So we create quiz questions after every topic, after every week we conclude. So there will be some quizzes, some assignments and some interview questions that we will discuss during the classes, which will be helpful for you to learn about them and enhance your knowledge. So that is first week's content that we are going to cover. And when I say that, I am excluding the trial class of today from there, because today's class, I assume it's more of a discussion of what we are going to cover so that we can have a perfect match between your expectations and the content we are covering. Then once you become comfortable in these concepts, then we move on into second week, we move on to the object-oriented programming concepts. And this second module we split in 2 weeks because these concepts are heavy and they require more mastery, more practice. So in one weekend we cover 2 concepts, another weekend we cover 2 other concepts. So what we do, we kind of, when in one weekend we are covering 2 object-oriented programming concepts, that time we bring in some easy topics from third unit, from third module here, so that we are making the good progress on our project, on our course also, and it gives you time to grasp the concepts also. So in second week, when we cover object-oriented concepts, when we talk about polymorphism, abstraction, encapsulation and inheritance, we not only talk about the theoretical details of that, but we apply them in building something small, something interesting. So we will do a simple case study here where we will be building a mini shopping cart. I guess I have that here. So it's a shopping cart designed in an object-oriented way. There is inheritance involved, there is polymorphism involved, and this depicts a shopping cart that we see on typical websites. So if I do a plus here, one item is there in my cart and the item price, total price that I have to pay is 45 because that's the cost of one pineapple. Now if I go and add apple here, I do plus here and apple is added. I do plus in pomegranate, that is added. So like that we can keep on adding some items and our shopping cart price is going up. Here minus I have disabled intentionally, but that's an extension. If you are interested taking it to next level, you want to implement that feature also, then sky is the limit. Basically whatever more time you want to put into building anything, that's all up to you. More you do, more you learn. So in this application we apply all the object-oriented programming concepts, and there is another one that we do, anagram game. Okay, that also I did not put here, but we will be taking a look at anagram game also. That is also we cover in second week. So third week when we come to, we talk about strings, collections. Now collection is a very important topic because in a lot of people who have done Selenium development also or Selenium exercises also, they will know like collections are used heavily there, and collections plus loops, they together are used. So we will talk about collections here, we will talk about string class, we will talk about exception handling. So these are the concepts that we cover in third unit, and the applications we develop here is auto completion. So let me see if I have auto completion. Okay, here it is, auto suggest. So this is a clone of Google search page. In Google, when we start typing something, if I say T H, okay wait, this is not working. Well, let me swap my dictionary file because its data source is dictionary sentences. It is using this file. In words file I have lot of words. You will see these words are acting as data source for this project. So if I go to auto suggest, now if I start typing T, you see all the words starting with T are listed. If I say H, then words with TH will come, A, I, and we will be developing that these kind of applications in class step by step, so that we can see how real world projects use these Java concepts, and adding GUI adds another dimension. It gives more satisfaction, it gives more sense of we have created something from scratch. And then there is another application here which is simple one, login and registration validator, where we have a form. Let me see if I have that. Okay, I did not include that also here. Let's say we have a form where we are putting username and password, and the application takes the username and password. If they are valid, it tells back that you are logged in, otherwise it responds back that login failed. So that is the easy one that can be covered here. The last unit is more on the UI, because UI is a very nice way of doing development. We can create something that we can share with others, and here you can say we will be doing a complex application called MiniPaint. And MiniPaint is like a clone of Paint application that we see in most of the platforms, be it Unix, be it Mac, be it Windows. So we'll be developing one small Paint kind of applications. Okay, I have it. So this is a Paint application, you can see, which uses little advanced concepts of UI. I can draw a oval, I can change the color here, and I can select another shape, rectangle. I can draw a rectangle here, then I can again go and change the color, and this is rectangle, or I can go and draw a line. Now these shapes were filled. We can uncheck this, we can go to rectangle again. This time we are able to draw unfilled rectangle. Then there is a feature of undo. One by one, anything that we have drawn are going. Then we have clear, which clears everything. A small application with buttons, with checkboxes, with drop downs, how all these things work. These are something that we cover in module 4. And you will realize by the time we go to module 4, some of these concepts we would have already covered, because before that we start building applications which involve UI. Auto completion we talked about, shopping cart we talked about, deck of cards we talked about. All these applications are anyways using Swing. So before we go to Swing and event handling, we would have used that in few applications. Here it is, main concept is we are covering the theoretical details of how they are linked, what classes are involved, what is inheritance relationship between all of them. And one additional topic that we cover here is we talk about the concept of streams. How do we read from files? How do we write to files? Because some of the applications that we are going to build, they will require the file handling concepts. So you saw auto completion is reading a file here. So auto completion was reading this file which has all the words. There are a few more applications also. These are from the previous batch that we covered. In your batch we have done some additions, some subtractions from the previous ones. So one more of previous I can show you is a friend viewer. This you can see there are people's name in this list in drop down. I change the name, the details of that person come here. This is the email, this is the department, this is the pic, this is another name, another name. So we can keep on swapping between the names and we can figure out the details. So this you can say is a small address book kind of application, Swing based. Yep. So apart from what is listed over here in this syllabus, there is one additional thing, two additional things that we thought of covering in this particular batch. I think I mentioned that in email also. One is we are going to get exposure to GitHub, and that is where we will be storing all our code. So GitHub is a central repository of code that that allows us to do parallel development, and it has version control also. Parallel development and version control. So you'll have an introduction of GitHub and you will be starting working as a developer. So when we develop MiniPaint application, because that's little bigger and that's the kind of main project, you can say one end-to-end application that we'll be building as part of this training. So we will be doing a collaborative development there. That means we will be distributing exercises among all of us, and you people will be working on one certain area, and we will be combining all the code together to make MiniPaint. So there we will do a collaborative development, which I said parallel development. And if you have more zeal and passion, then I have an open source project idea, and it is testing related, just to give you exposure to more testing side also. So if time permits and if you people are able to do things fast, then we may include one more area, that is one open source contribution. and that is extension of Selenium. In Selenium, in execution of Selenium, we can contribute something. I have figured out one opportunity there which we can develop and we can build. So that also we will discuss going forward in classes. Selenium contribution. And these kind of things, when we do, it is more satisfying that we can say like we have also contributed to the open source world. And all these applications, if we are able to do successfully, okay, we didn't talk about quiz app, so there is a small quiz app where we can host a quiz. Okay, that also I don't have here. Fine, it's an app where we show quiz questions, 4 radio buttons, 1 question, and we have to select the answer. Right or wrong answer is told by the application itself. Yeah, so that is about the course overview that we are going to cover and we are going to have in this series. Any questions? Yeah, Sushma, you have any question? Yeah, Srinivas.
Together we are going to have 4 weeks of training?
Exactly.
Exercise everything. Okay.
Yes,
Okay.
yes.
And what will be the timings for this sessions?
The timings that are comfortable for me are 9:30 to 11:30, Saturday, Sunday night, India Standard Time. I'm telling.
Okay.
9:30 p.m. to 11:30. It's a 2-hour session every Saturday, Sunday that we do. Now, in case all of you want to change the timing to some other time, I mean, if you want to make it 8:30 to 10:30, I am comfortable with that as well, so that we can see based on everyone's comfort. If you have any concerns related to the timing, feel free to talk to me after the class or over emails. Only challenge faced by people in this timing is there are some people from Australia who have joined the training, and for them kind of it becomes little odd timing. I think it's Australia and Sweden. Those are the two countries from where people face challenges, and they finally agree to say like, okay, we'll watch the recordings and any doubts that we have, just give us 15 minutes in a week where you can sync up with us on our timings, our comfort timings. So I do that for those people. So in this batch also, I see there are 2 people from Australia, and we'll be doing, I'll be handling them separately. So they have agreed they want to watch the videos and they want 15 minutes separately to discuss their doubts in case they may have. But Srinivas, is this timing comfortable for you? At least you people are there, so I can ask directly.
Yeah, I'm good with time slot.
Okay. How about you, Sarita?
Yeah, it's okay. Yeah, it's fine for me as well. Yeah.
Okay. Sushma? Okay, great. Fine. So if there are any changes, I'll inform you. Otherwise, we'll be sticking to this time itself. Now to why? Yeah.
After each session,
Do we get?
recorded.
Yeah. Yeah. So all these sessions are getting recorded, and you will have access to the recordings of the session.
Okay, thank you.
Yeah. Well, so we have taken a look at course overview. So there is one slide of exercises that I have created. It's for you to explore. So first exercise that I'm leaving for you to explore is, my name is, you can put your own name, but your name should come in output as in double quotes. So this is one program that you can try on your own. And tomorrow's class, tomorrow also we are going to have a discussion around same time, 9:30 to 10:30. Tomorrow also we'll keep it 1 hour. So we'll have a discussion about what your findings are in these 2 programs. So first one is, write a program which prints, my name is something in double quotes, dot, I am, how many years of age you are, you can put them in single quote. So this is the output we are expecting from you in a Java program. So this will give you enough exercise to do a command line based program writing, compilation, and seeing the output, whether you are getting this output or not. Second question as an exercise being given here is, find out the differences between, today we used system.out.println. There are 2 more ways in Java to do output, which is system.out.printf and system.out.print. What are the difference between these 3? That is what needs to be figured out, and you can write a program where you are printing this statement using all 3 functions. Well, so that was it. That was planned for today's class. Any more questions or any questions related to the topics that we covered today? Okay, if there are no questions, then that will be end of today's session. Then I'll see you tomorrow. Another is I will be sharing this exercise and the course content with all of you. I will be uploading them to a shared location in Google Drive, and you will receive a mail from me using which you can go over the slides and you can do the exercises. Plus, I will also share the YouTube playlist where I am going to upload the video of today's class so that you can watch it tomorrow. Yeah. Okay, thanks guys for your time. Then hopefully we will meet tomorrow same time.
Thank you.
Yeah.
Okay, thank you.
Okay, thank you. See you tomorrow. Yeah, bye.